So basically it's asking what the definition of electrolysis is. So we've got some people saying B, we've got some people saying C. Definition is in the name. Electrolysis, there's two parts to it. There's the electro part, so that means electricity, and the lysis part means split up. So it's basically splitting up a compound using electricity. That's what electrolysis means, okay? So in our answers here, an electrical current causes a physical change. No, a physical change, that would be like changing the state of a compound or something. That wouldn't be right. Purifying compound, no, it doesn't purify it. Electrical current creates a compound, no, it doesn't create. It breaks up or breaks down a compound. Decomposes means it breaks down a compound. So the answer is it decomposes a compound, okay? Next up, positive ions move towards the what? So this is where we need to think about the different types of electrodes you can have. Start that again. So positive ions move towards the, what do we think? What's the difference between the anode and the cathode? Let's look at our notes here. So we've got two electrodes. These are both called electrodes, and you can have a positive electrode, which is called the anode, and the negative electrode is called the cathode. Okay, so to remember that, there's three things we can use in electrolysis that helps us remember things. There's oil rig, which is probably the most common one that you learn. There's panic, and there's ORAC. We'll come back to the bottom one in a second. Does anyone know what oil rig stands for? Comment if you think you know what oil rig stands for. What does the OILRIG stands for? Oxidation, yep, thank you. Oxidation is loss and reduction is gain. Good, reduction is gain. So that's handy to remember the definitions of oxidation and reduction. So what we're talking about, a loss and gain of electrons. All right, then we've got panic. This one here is used to remember the two electrodes. So remember I said we've got two different electrodes. We've got the positive electrode and the negative electrode. Yep, well done, thank you. Panic, positive electrode is the anode and negative electrode is the cathode. That's how to remember which one's which. Where was I on Friday when I had the chem? Sorry, I didn't have time to do a live Friday, but it was Friday evening anyway. It wasn't Friday morning. So if you had your test, it would have been earlier in the day. So yeah, I had to do it today instead. Next up, so positive ions move towards the, okay, so we got positive ions. What are positive ions going to move towards? They're going to move towards a negative electrode. Let me change that. Negative electrode. So which one's the negative electrode? What's the answer going to be? So remember here you can use panic to remember. Positive anode, negative is cathode. So we want the negative electrode. So the answer is going to be the cathode. Yep, well done guys. All right, so let's look at a exam question here about electrolysis. Choose the answer from the box. Copper chloride can conduct electricity when in solution or when, what do you guys think the answer is? Molten, yep, most of you saying molten, yes. Does anyone know why it only conducts electricity when it's molten or in solution? So this is something that we learn in the bonding topic. So another word for solution is aqueous, and molten basically means it's liquid. So does anyone know? Because it can't conduct electricity as a solid. So what's the reason why? Because, not because electrons can move. No, this is a common mistake people make. They think it's because electrons can move. This is all to do with ions, guys. These are ionic compounds. It's all to do with ions. It's because ions are free to move. So let's write this down here. So this liquid in the electrolysis setup, we call that the electrolyte. The electrolyte. And the electrolyte is basically, let's write up here because this is important. The electrolyte is an ionic substance. So what we learned in bonding, if you weren't here for my live on bonding, check it out. It's on YouTube. We went through this. Ionic substances conduct electricity only when they're molten or aqueous. And the reason why is because they have free moving ions. That's important, not electrons. So the ions are free to move. So you can have one set of ions going to the cathode and one set going to the anode. So there are 4 ions in the copper chloride solution. We've got Cu2 plus, Cl minus, H plus and OH minus. Why do Cl ions and OH minus ions move to the positive electrode. What do you guys think? Let me know. Let me answer these questions. Do I have a YouTube? Yep, the YouTube is Flash Revision Lab. So I've got all my other lives uploaded on that with these questions and the notes on it as well. So check it out definitely if you want to watch any of my past lives. So answer, most people are saying because opposites attract. That's exactly right. Because the opposite charges, these are negatively charged, this is positive, so you can literally say opposites attract. So opposite charges attract. So let's check the mark scheme. Yeah, first one was molten, opposite charges attract, or you could just say the ions are negatively charged. Okay, let's move on to the next question. Molten ionic compounds can be electrolyzed because, so this is what I just said, so everyone just quickly vote what you think the answer is and tap on the screen a few times. Why can they conduct electricity? Don't make the common mistake that I said. Yep, good. So you guys are learning from what I just taught you. So that is a common mistake. Remember, it's not because electrons are free to move. Not because electrons. Not for ionic compounds anyway. Electrons that are free to move. What is that for then? Electrons that are free to move. When do we talk about that? Does anyone know? Because this is a very common mistake. In what type of substance are electrons free to move? Metals, yep, thank you. So one of them's metals and there's one more in metals because they've got a sea of delocalized electrons. Again, guys, go check out my live on bonding if you want to recap that topic. It's metals and there's one more. Giant molecular structure is giant covalent structure. There's one giant covalent structure in particular that conducts electricity, or one or two. There's two. Does anyone know the name? It's one of the allotropes of carbon. Yep, it's graphite. So graphite / graphene, they have free moving ions. That's why they conduct electricity. Okay, so remember these three things. These two things, they conduct electricity because they have free moving ions. But if it's an ionic compound, that conducts electricity because it has free moving... Sorry, these two have free moving electrons. Ionic compounds have free moving ions. Okay? Not diamond. Diamond doesn't have any free moving electrons, so it doesn't conduct electricity. So the answer to this question is C. Ions are free to move and can conduct electricity. Okay, next up we got another exam question here. One of the products of electrolysis of sodium chloride is hydrogen. Why do hydrogens move to the negative electrode? Again, this was just like our previous question. So you guys should be able to tell me straight away. Opposites attract, yeah, because it's positive. So here we should state that they're positive because before they told us the other two were negative. Here they haven't told us, so we say they are positive and positives attract and opposites attract. How does a hydrogen ion change into a hydrogen atom? So it is to do with electrons. So it could either gain or lose electrons. They gain electrons. How do we know it gains and not loses? Because hydrogen is H+. Plus indicates it has too few electrons. So it has less electrons. And what needs to happen is it needs to turn into hydrogen atoms. So in electrolysis, you always start off with an ion and the ion turns into an atom. So this is a positive ion. So it has few electrons. It doesn't have enough electrons. Too few. I'm going to write that symbol for electrons. To become an atom, it needs to gain electrons. Gain electrons. So that happens at the cathode. That happens at the cathode. So let's go back to our notes. So here at the cathode, what do we have? We have electrons being gained. So let's write that down. Anode is the opposite, the loss of electrons. And here, this last acronym for you to remember, ORAC, that's just to memorize that there's oxidation at the anode and reduction at the cathode. So I don't think many teachers teach this at school. So oxidation at the anode, and we know oxidation is loss. So at the anode, we got electrons being lost. And then for reduction at the cathode, we know, reduction, we know is the gain of electrons. So at the cathode, we got the gain of electrons. Hope that makes sense. Let me know if that makes sense, guys. I just set a poll, let me know, and I'll move on. Or tell me if you want me to explain that again. Yep, we're looking good. So let me say that again. So at the cathode, we got electrons being gained. You've got a positive ion going to the cathode. So a positive ion goes to the cathode because it gets attracted. And then we have a negative ion going to the anode. And at the anode, electrons are lost. and at the cathode, electrons are gained. Okay? All right, let's move on to the next question. So how does a hydrogen ion turn into a hydrogen atom? It gains electrons, just like you guys said. And that's what we get our marks for. So positively charged and they're attracted, and they accepted. Opposites attract, and then gains an electron here. On to the next one. Negative non-metal ions are oxidized to the element at the... Okay, what do you guys think for this one? Down your answer and tap on the screen a few times. So remember the acronym ORAC. So remember what it stands for. Oxidation at anode, reduction at cathode. This question is asking where is it oxidized? The answer is going to be the anode because there's oxidation at the anode. Yep, well done, most of you got that. That's good. Okay, next up. In the electrolysis of copper 2 sulfate with inner electrodes, what is produced at the cathode? Okay, so here you need to recognize what ions are present. So what happens is, here we have a molten, let me open this up again. Here we have a molten electrolyte, okay? So in molten electrolytes, for example, if we had something like sodium chloride, first thing you need to do is you need to recognize what ions are present in here. Sodium chloride, there's 2 ions present. There's sodium ions, those are Na+, chloride ions, those are Cl-. Okay, and those are floating around in here. In this electrolyte, you just have Na+ ions floating around, loads of those, and then you have chloride ions floating around. And then when you turn the electricity on, positive ions go here, the chloride ions go here, the negative ones here. And then using ORAC, so remember this one is the anode and this one is the cathode. Here we have oxidation. So at the anode we have oxidation. So what's happening here is the Cl- loses electrons to become, so remember in electrolysis you always go from ion to atom. So it loses electrons to become a Cl atom. On the other side here, on the cathode, is the opposite. We have reduction. Here we got Na+. Remember, ion to atom. Let's write that down at the top. But let's put in the memory tips. In electrolysis, we go from ion to atom. That's always the aim, or big box around that. Ion to atom. So here we're going from Na+ ion. This time it gains electrons, because remember, this time oil rig reduction means gain. So it gains electrons to become an atom, which is sodium metal, so Na atom. So here, what is produced at the cathode? So cathode, if we look back here, cathode is where the positive ion or the metal is produced usually. So out of these two, we got copper sulfate. Copper sulfate is something like CuSO4, okay? We got 2 ions here. We got copper ions, Cu2+, and we got sulfate ions, SO4 2-. So out of the two, which one's produced at the cathode? What do you guys think then? Or what is produced at the cathode? Nope, it's not hydrogen gas. Remember, at the cathode, we said it's when you have the positive ion gaining an electron. So the positive ion is copper. Remember, ion goes to atom. So your copper ion goes to a copper metal, copper atom. So the answer is copper metal. Answer's A. So let me explain that again. Electrolysis of copper 2 sulfate. This is copper sulfate, okay? We've got 2 ions here. We've always got a positive ion and a negative ion. So positive ion is copper 2+, negative ion is SO4 2-. What is produced at the cathode? At the cathode, it's always to do with the positive ion because the cathode is the negative electrode. The ion turns into atom. So your Cu2+ turns into Cu atom, okay? Hopefully you'll get this by the end of the session. Next question. We've got exam question here. Where do H+ and OH- ions come in the electrolysis of copper chloride solution? So this one's not molten. This is a solution. This is aqueous. It changes a bit when you're dealing with aqueous solutions. The answer is water. That's because anything in solution, so let's look at aqueous electrolytes. So you see here, we looked at sodium chloride molten. Let's look at sodium chloride aqueous. So sodium chloride molten only had 2 ions here, Na+, Cl-. But when you're dealing with sodium chloride aqueous, so in solution, that means it's dissolved in water. So there is also some water in your solution. Now water can break down into 2 additional ions. It can break down into H+ ions and OH- ions. So whenever you have an aqueous electrolyte, you have the original ions from the substance, so Na plus, Cl minus, but you have an additional H plus and OH minus on top of that. So here we're dealing with 4 ions. So in this solution here, we got all 4. We got Na plus, we got H plus, we've got Cl minus, and we've got OH minus ions. All of those are floating around the solution. Before, we only had Na plus and Cl minus. So that's the difference between molten and aqueous. So look carefully at any questions that you have. If they say solution, they mean aqueous. In the other example, they'll say molten. Which ion produces a metal? So out of these 4, which one would produce a metal, do you think? Yeah, there's only one metal in there. It's copper. Chlorine's not a metal, that's a gas. That's going to produce a gas. OH minus, if OH minus ever goes, produces water. So yeah, it produces water and oxygen. So the answer is Cu2 plus. And that's exactly what the mark scheme says. Okay, what is produced at the anode in the electrolysis of aqueous solutions when no halide ions are present? Okay, so this is where it gets complicated with aqueous electrolytes. So here, let's go back to our example here. We had sodium chloride. At the anode, chlorine loses electrons, so Cl minus ions lose electrons to become chloride. What are halide ions? Halide ions are group 7 elements, okay? So here, you can write a half equation. A half equation is just an equation that tells you what happens at the anode here. So here we've got Cl minus ions turning into Cl atom ions. Sorry, Cl atoms. And they lose electrons. So we put electrons on the right hand side here to show that it's being lost. Now what you need to remember here is chlorine is diatomic. Any group 7 element is diatomic. So we call that Cl2. And then to balance this equation, we need 2 Cl minuses and 2 electrons. That's the half equation at the anode. Now, if we look at the cathode, remember it's always ion to atom. So we've got Na plus on the left, and that's going to form Na atoms. It gains an electron. So what we do here is we put the electrons on the left. That's how to write the half equations. So with molten electrolytes, it's quite simple because you've got 2 ions only. You don't have any other ions. What makes aqueous complicated is that there are 4 ions present now. So what you need to do is you need to decide which positive ion is going to go to the electrode and which negative ion is going to go to the electrode, because there's a choice of 2. So out of the 2 positive ones, is it going to be Na plus or H plus? And out of the negative ones, is it going to be Cl minus or OH minus? So what you need to do here is follow these 2 rules. So let's write down deciding which ions go to the electrodes. Okay, so at the cathode, we have 2 at the cathode. We've got either Na plus or H plus. It's whichever one that is less reactive that goes. So remember it like that. So out of the 2, the less reactive element goes to the cathode. So out of Na plus and H plus, so out of sodium and hydrogen, which one is less reactive? This is where it's important to know the reactivity series. Hydrogen, exactly. So here it would be hydrogen that goes, not sodium. What is the rule then for when you've got the anode, when you need to decide at the anode? Is it Cl minus or is it OH? Does anyone know what the rule for that one is? No, this one's not to do with reactivity. No, this is another rule. Halide, yes, it's always to do with halides. So remember what halides are. Halides are group 7 elements. So it could be fluorine, chlorine, bromine, iodine. If there's a halide, the halide goes. If there is no halide, OH minus goes. So let's write that down as well. Remember, halide is group 7. If halide is present, goes to the anode. So the halide would go to the anode. If not, then OH minus goes. And if OH minus goes, oxygen gas is produced. I hope that makes sense. This is where it gets confusing, okay? So I hope that makes sense. Hopefully we'll see a few questions on this. So back to deciding which one's going to go. Out of these 2, which one's going to go? Cl minus or OH minus? Chlorine. Yep, well done. So chlorine's going to go because chlorine is a halide. So halide is present, chlorine's going to go. So what you'll see for aqueous electrolytes here, this side, the H plus is going to go. So what you're going to get is bubbles of hydrogen gas formed. On this side, you're going to have chloride ions going. And when chloride ions go, you're going to get bubbles of Cl2 gas. So to write the half equations, the one at the anode is exactly the same because it's still chlorine. Remember, even in molten, it was still chlorine. It's the same. It's 2Cl minus goes to Cl2 plus 2E minus. If you compare the positive ones, here we had sodium going, but here because we have hydrogen and hydrogen is less reactive than sodium, the hydrogen goes. So hydrogen ions turn into hydrogen atoms. And how does it turn? It gains 2 electrons. The reason it's 2 is because hydrogen is also diatomic. So you got H2 here, and then we need to balance the equation. So we put 2H plus here and 2E minus here. So that gives us our 2 equations. So you can see just by changing it from molten to aqueous, even though it's both sodium chloride, we've completely changed what gets formed at one of the electrodes. So let's go back to our question. What is produced when no halide ions are present? What do you guys think now? Vote on your answer and tap on the screen a few times. Yes, you guys are getting it. Well done, guys. It's oxygen gas. No halide ions are present because when there's no halide ions present, then OH minus goes and OH minus forms oxygen. How do you know which elements are diatomic? You have to memorize these. Let me tell you. Let me write them down here. So memory tips. There's no tips for this. You just need to memorize. Oh wait, there is a slight tip I can help you with actually. So on the periodic table, it kind of forms like an L shape. Color. All of this, an upside down L. All of these. So all of group 7, all the going up to L. All of these are diatomic. So nitrogen, oxygen, and all of group 7. Plus one more, which is hydrogen. So let me write those down on the memory tips page. Remember, you guys can download this when I upload it to YouTube. So diatomic elements to memorize. We had hydrogen, we had nitrogen, oxygen, and then group 7. All of group 7 is diatomic. That's another thing to memorize. Okay, on to the next page. In the electrolysis of sodium chloride solution. Okay, we've literally did this in our notes. Sodium chloride solution. Remember, solution means aqueous. What is formed at the anode? What do you guys think? Let me know now, based on what I've said. At the anode. So remember, sodium chloride, it could be... Oh, I gave you the answers. So sodium chloride, it could be Na+. Yeah, most of you are right. What does diatomic mean? So diatomic basically means it exists as 2 atoms in a molecule. So chlorine is diatomic. That means when you have chlorine gas, it's not Cl, it's Cl2 because it exists as 2 atoms of chlorine. So that's one atom of chlorine, that's another atom of chlorine, and together they make a molecule of Cl2, diatomic. So yeah, answer is chlorine gas. That's what we did in our notes here. We've got the aqueous one, and we said that chlorine gas is formed here. Okay, next question. The half equation for the reaction at a positive electrode during the electrolysis of sodium chloride. Again, we've done this. Which one do you think the answer is? Positive electrode. Remember, positive, panic. Positive is anode. Positive is anode. Negative is cathode. So we want the equation at the anode, the positive one. So what gets attracted to the positive one? It's going to be a negative electrode, a negative ion. So people are saying, someone said B. Yep, we're saying B. So we're looking for the negative electrode. Sorry, we're looking at the positive electrode and we're looking at the negative ion. Sodium chloride, we've got Na+ and we've got Cl-. So which one's going to get attracted to the anode? It's going to be the Cl-. So we want the equation for Cl-. Now the question is, it's not that, it's not that. It's either this or this. Remember what I said in our notes. It always goes from ion to atom, ion to atom. So it's going to be ion on the left-hand side, atoms on the right-hand side. Sorry, the formatting is weird on this. It should be Cl2, small 2, yeah? So it's not this one. Answer's B. Well done, those of you who got that. When a halide ion is present in the aqueous solution, the ion at the anode will form... We said this already, the answer already to this one. I think I put it in twice because... wait, have we done this one? And at the anode, so you guys are saying B, it will form the non-metal. So if we had sodium chloride at the anode, we're going to have chlorine going, yep, and it's going to form Cl2 gas. That's what we wrote in our notes. The answer is going to be the non-metal, yep, well done. Answer's B. Which gas is produced at the cathode during electrolysis of aqueous sodium chloride? So the cathode here, cations, we're talking about positive. Remember, don't get confused here because this is aqueous. What's the answer going to be? It's not going to be, it's definitely not going to be chlorine. It's not going to be oxygen because it's talking about positive. It's either going to be hydrogen or sodium. And then how do you decide which one it is? You basically go with the less reactive one out of hydrogen and sodium, which is hydrogen in this example. So the answer is, yep, well done guys, C. All right, on to an exam question. This question is about electrolysis of aqueous solutions. Hydrogen gas and chlorine gas are produced when sodium chloride solution is electrolyzed. Hydrogen ions are attracted to the negative electrode. The half equation for the reaction, this. What type of reaction happens at the negative electrode? Can anyone tell me what that is? The negative electrode. So remember, for this one, you can use O, should be A. Oxidation at anode, reduction at cathode. And which one's the negative electrode? It's the cathode. Yep, so the answer is reduction. And the reason for that, based on this equation, is because it's gaining electrons. Well done. Next question, complete the half equation for the production of chlorine gas. So they've given you a clue here. They've told you it's Cl2. So we need to add Cl2 here. And they've given you a line here. So you need to add something here. Every half equation needs to have an electron in it. So that's all 1 mark. For the second mark, you need to balance all of this. You've got 2 chlorines here. So you need 2 chlorines here. And that means you need 2 electrons as well to balance it. That should be the answer. Yes, well done, those of you who are getting it. Okay, now we've got a 4 marker here. Hydrogen gas and oxygen gas are produced when sodium sulfate solution is electrolyzed. Explain how oxygen gas is produced. How oxygen gas is produced at the electrolysis of sodium sulfate solution. So we've got sodium sulfate. So let's think about what sodium sulfate has in it. It's got sodium ions, sulfate ions. Remember, this is aqueous because it's a solution. So it also has H plus ions and OH minus ions. How is oxygen gas produced? So for this one, we need to look at the negative ions. Do you guys remember the rules for the negative ions? So this was the one with the anodes. So we said for the anode, if a halide is present, then the halide goes to the anode. If the halide is not present, then OH minus goes to the anode. Is a halide present here? We've got SO4 minus, OH minus here. Are there any halide ions present here? So halide means group 7. So it would be fluorine, chlorine, bromine, iodine, something like that. There are no halide ions. So according to this, OH minus is going to go and oxygen is going to be formed. So we need to basically explain this for 4 marks. So what can we say? We got, okay, we're saying, someone's saying water molecules are broken down. Yep. So we got water molecules are broken down and it produces, so remember the 2 things that water produces are H plus and OH minus ions. We're not really worried about the H plus ions here, but you can mention it. This is all about the OH minus ions. And then you mentioned what happens to the OH minus ions. Yep, so the OH minus ions goes to anode. Someone asks, wouldn't the OH minus at the anode produce hydrogen and oxygen gas? No. Let me show you what the actual half equation is. So if OH minus ever goes to your electrode, where should I write it? Let me write it here. This is the reaction that happens. 4OH minus loses electrons to form O2 plus H2O plus 4E minus. That's the equation that happens. This is one equation that you always need to memorize. All the other ones you can pretty much figure out using the periodic table, but this one you need to memorize. So you can see here what happens is when the OH minus ion goes to the electrode, it produces bubbles of oxygen and it produces water. The water just goes back into the solution, so you don't really see anything. And then it forms the electrons as well, okay? So that's what it gets formed. So here we said OH minus ions goes to the anode, and then you can say the OH minus ions lose electrons, because remember, we've got oxidation happening here. Lose electrons to form oxygen and water, but we don't need to mention that because the question's asking about oxygen. So that's how you get 4 marks here. So let's look at the mark scheme here. First one, we said reduction, yes, because electrons are gained. This was fine as well. Now let's look at the last question. We mentioned water molecules, yes, they get broken down to form OH minus, yes. We mentioned H plus as well, that doesn't matter, that'll just get ignored. These OH minus ions are attracted to the positive electrode. We said anode. Yes, that's the positive electrode. That's fine. And there, oxidation happens. So we mentioned that it loses electrons. These lives I try to do twice a week, Saturdays and Fridays. I didn't do one yesterday, so I'll probably do one tomorrow to make up for that. Okay, I hope that made sense. Let's go on to another question. So tomorrow's live will probably be at 6. If electrolysis is performed on copper 2 bromide using electrodes, bromine will be produced at... Okay, so the question is asking bromine. Where would bromine be produced? Cathode, anode, electrolyte or power supply? Vote what you think the answer is and tap on the screen a few times. People going with B? Yep, B is absolutely right. Anode, because bromine is Br minus, it's negative, so it's going to go to the positive electrode, which is the anode, because of panic. Panic means positive anode. The process of electrolysis involves the flow of... What do you guys think this one is then? A, B, C or D? We've mentioned this already earlier in the live. Remember, don't make the mistake that I say most people make mistakes on. So answer is either A or B. There's nothing to do with protons moving. Protons don't move. And it's nothing to do with neutrons. Yes, you corrected yourself. It's the movement of ions, not electrons. Electrons are for metals and for graphite or graphene. That's the only time you talk about free moving electrons. Ions are for ionic compounds. Free moving ions are for ionic compounds. The answer is A. During the electrolysis of molten calcium chloride, calcium metal is produced at... So calcium is a metal, Ca2+. Is that going to be produced at the anode or the cathode? It's not going to be the last two. That doesn't make sense. It's one of the electrodes. Remember, it's panic. This is a positive ion. It's going to go to the negative electrode, which is the cathode. This is cathode. Yep, well done, guys. All right, here, electrolysis of aluminium. So this is one specific one that you need to know for your exams. Aluminium being extracted. So in this, you've got your electrolyte. Let me write this down in our notes. So electrolysis to extract aluminium. So in this, you have an electrolyte. The electrolyte is made up of a compound of aluminium, aluminium oxide, and one more thing, it's mixed with something. Does anyone know what it's mixed with? It's only for this one. Only for aluminium you need to know, and it's a special case. Yeah, cryolite. It's called cryolite. And does anyone know why cryolite is used for extracting aluminium? What does the cryolite do? It lowers the melting point. It basically makes it easier to electrolyze, because you want to get molten aluminium oxide, but the problem is it has a very high melting point, so it takes a lot of energy to melt it into a liquid. If you mix it with cryolite, it just lowers the melting point a bit, and that just makes it cheaper to heat up and make it into a liquid. That's one thing. So let's go back to our question here. What is meant by the term reduction? Yes, most of you said this earlier. It's the gain of electrons because of oil rig. We can say that. Okay. I thought it said loss of electrons. I just realized loss of oxygen. We said gain of electrons. That's fine. You can say loss of oxygen as well. Yep. Oxygen is formed at the positive carbon electrodes. Explain why positive electrodes must be continually replaced. Anyone know why? This is again specific to the aluminium one, because in aluminium we've got two ions. We've got Al3 plus ions in the solution, and we've got O2 minus ions. So the ions here turn into aluminium metal. That's what we're trying to extract. Here, this forms oxygen gas. So at the anode, you're going to get oxygen gas. Does anyone know why the electrodes in the anode, so remember this is cathode and this is anode. So why does the anode need to be replaced all the time? Because it says the positive electrodes. They form a protective layer to stop the reaction. No, lots of oxygen bubbles will be formed around it. It's something to do with the oxygen. It does something to the carbon. It basically wears away the carbon. So these electrodes, all these electrodes, let's write it down here at the top. These electrodes are made up of carbon, they're graphite, okay? So if you use carbon and oxygen, loads of oxygen is produced, what happens is the carbon combines with the oxygen or reacts with the oxygen to form carbon dioxide. And what this does is it wears away the electrodes. So that's the reason why you need to keep replacing it. You need to keep replacing the electrodes. So explain why positive carbon electrodes must be continually replaced. You can say because oxygen reacts with carbon, we'll say with the carbon electrode. How many marks is this? This is 3 marks. So we can say to produce CO2, carbon dioxide, and what does that do? That wears away the electrode. Okay, next question. A substance conducts electricity because of free moving charged particles. Remember what I said, it could either be electrons or it could be ions. What are the free moving charged particles? Okay, so I've said this a few times in this session. Let me know. What are free moving in graphite electrodes? Molten mixture of aluminium oxide and metal. What do you guys think? It could either be electrons or ions. So the first one, in an electrode, what would it be? In a carbon electrode, it would be electrons. Yes, well done. Electrons in the first one. We've got delocalized electrons. Then we've got a molten mixture of aluminium oxide. Aluminium oxide is ionic. So, yep. Well done, guys. You guys are understanding this. This is good. Molten mixture of aluminium oxide. That's going to be free moving ions. And the last one, anything that's metal, is free moving electrons. So like I said, guys, if you want to go through this stuff, go to my bonding live. That's on YouTube. And we go through everything in bonding. Ionic, covalent and metallic bonding. And we've got a similar setup. We've got questions, exam questions and notes on that. So let's just double check these answers. We said oxygen reacts with carbon. Yes, the carbon wears away. Produces carbon dioxide. We mentioned all three of that. Delocalized electrons, ions, electrons. We mentioned that as well. That's good. All right. The substance that is decomposed in electrolysis is known as... This is a quick one, guys. What's the answer to this? We got one more exam question I want to get through and then we'll call it a day. Thing that's getting decomposed. It's B. Well done, guys. Electrolyte. It's the liquid. That's what's getting decomposed. That's what's getting broken down. When electrolyzing a molten ionic compound, the metal form is formed at the... Again, it's not going to be electrolyte or power source. It's going to be one of the electrodes. Is it anode or cathode? Let me know. It is. It's the cathode. Well done. In the industrial extraction of aluminium, aluminium is mixed with... Okay, I mentioned this literally 5 minutes ago. Answer for this one. Again, let's make it a quick one and tap on the screen a few times, guys. So this is all in our notes. Yep, cryolite. It's mixed with cryolite. Well done. The purpose of adding cryolite to the electrolysis of aluminium oxide is to what? I'm going to do one more poll, guys. Let me know. Do you feel better about electrolysis or not after this live? I'm hoping it's better. Let me know. I hope this helped and tell me what you think the answer is. Amazing. Sorry for those that it hasn't helped, but good to hear that it is helping most of you. Purpose of adding cryolite to the electrolysis of aluminium oxide is to lower the melting point. Remember, it makes it more efficient. It means less energy is used to melt it into a liquid. Okay, last exam question here. Magnesium chloride can be electrolyzed. The diagram shows two experiments for magnesium chloride. Okay, so the difference between the two, look at this. Molten water, aqueous. So we got an aqueous example and we've got a molten. Molten just means it's in liquid form. So why is magnesium not produced at the negative electrode in experiment 2? It's talking about the aqueous one. So let's think first of all, what are the ions that are present in the aqueous one? We've got magnesium chloride, so we've got Mg2+, magnesium. We got Cl-. And remember, if it's dissolved in water, you also have H+ and OH-. Okay? Now, why is magnesium not produced? So this is when we start using our rules. What is our rules with positive ions? How do you decide which one's produced? Yes, someone's already said it. Less reactive. So back to our notes here. This is what we said. At the cathode, the less reactive element goes to the cathode. So here we had two positive ions, magnesium and hydrogen. So out of those two, it's the less reactive one that goes. So the answer is, it is less reactive than magnesium. We got to say what is less reactive because it says why is magnesium not produced? We'll say hydrogen is less reactive than magnesium. Or you could say magnesium is more reactive than hydrogen. And complete the balanced half equation. This is the one that we've seen a few times today now. So remember, chlorine is diatomic. I gave you a list of all the diatomic ones that you need to memorize. If you missed that, guys, remember, I'm going to upload this to YouTube with all the notes and the questions. I'll do that within the next week, at some point this week. So yeah, definitely check it out. Try and subscribe to my YouTube if you haven't already. And you can look at all my past lives. And yes, well done. Answer for this final one, 2Cl and 2E-. So let's just double check that with the mark scheme. Magnesium is more reactive than hydrogen. Yeah, we just said hydrogen is less reactive, so that's fine. That's the converse, except converse. And then here, got the 2Cl minus, Cr2 and 2E minus. All right, we're going to call it there, guys.